Now, before we continue with the notes on complex numbers and the division by complex numbers, we do need to review a little bit of this concept of rationalizing denominators. One of the things that we learned back in geometry and many other math classes is the fact that we do not like to divide by radicals or by square roots. And so, in order for us to get rid of those radicals, we would multiply the denominator and the numerator by not just any radical, but in this case, we would multiply it by radical 5. One of the reasons we do that, and yes, we cannot multiply the 3 and the 5, but we would end up with 3 square root of 5. And then notice at the bottom, it's radical 5 times radical 5. Technically, it's square root of 25, which of course means this is 3 square root of 5 because I can't do anything with those two. But then the square root of 25 becomes a 5. And so that's the idea we talked about the other day. We said when you have two radicals that basically repeat each other, then that just means one thing: a 5 comes out on its own. For every matching pair, one comes out. But this is what rationalizing the denominator was. We just didn't like dividing or having a radical or square root at the bottom of a fraction in our denominator. So that's why when I look at this one, it does say, okay, we're going to take the square root of 3 in the denominator, which of course we don't like. So because we don't like it, then we're going to get rid of it with a simple multiplication by radical 3 at the bottom, and of course in the numerator as well. These two numbers cannot be multiplied with each other, so we'll just write them next to each other as part of our multiplication. And like we said earlier, remember the rule. For every matching pair, one of the numbers comes out. So radical 3 times radical 3 ends up being just a 3. Now, this one does have a little special situation here, where if you look carefully, this is now an outside number, this is now an outside number, then you should always be reducing your fractions. Again, nobody has to remind you to do that. And so 6 divided by 3 is just a 2 with the radical 3 involved as well. And like I said before, when we were rationalizing denominators, we only did that if we had a square root in our denominator. But we have ways of getting rid of it. And all it takes is a little multiplication. But we did it to the bottom and we did it to the top of our fraction. Well, same situation coming up here again. When you look at our notes on page 46, it says dividing complex by complex numbers. So it says in math, we cannot divide by complex numbers. Now, there's a reason for that. Remember that a complex number, the I, technically represents a square root of -1. And if we're telling someone, well, we can't divide by a negative value, well, then if we can't divide by a negative value, we need to get rid of it. It can't. So in math, we cannot divide by complex numbers because we have a radical at the bottom of a fraction. So we need to rationalize the denominator. To do so, we need the complex conjugate. So that's the key right there. We're going to need what we call the conjugate of our complex number. Now, the complex conjugate of a plus bi is simply, all right, here comes the conjugate. First time we see this, of course. It would be a minus bi. Notice the only change. If this is a positive, then all we're going to do is change the sign in the middle into a negative. So, for example, the complex conjugate of -3 minus 2i, again, that -3 is fine. It's the middle term right here. That's the only thing that we're changing into a positive 2i. This would be the conjugate. So as it says there, the sign only differs on the imaginary part of the complex number. So let's give this a try. Again, when we're looking at these problems, the big concern is it says 1 minus 2i. Technically, that means, right, we have it up here. There's a radical at the bottom of our fraction. We have a square root. We don't want it there, so we have to get rid of it because it'll affect our problem. So here we go. I don't want a 1 minus 2i, so I'm going to multiply the top and the bottom of my fraction by the conjugate. If this one says 1 minus 2i, then the conjugate is 1 plus 2i. That's the conjugate we're looking at. And if I do it to the bottom, I have to do it to the top, just like I showed you earlier with our other problems from back in our geometry days. Now, this is where, of course, we get a little work going for ourselves. Here, it's a simple distribution. We saw that yesterday with the multiplication. And so we end up with a 3 plus 3 times 2 is 6 with an I. Now, we need to remind you of something here. They are conjugates of each other. So I have room down here. I want to show you something. Normally, we would take a problem like this, 1 minus 2i times 1 plus 2i. So again, I'm just showing you the bottom here, down below a little bit. We would normally multiply 1 times 1 is 1. 1 times 2i is 2i. 2i times 1 with the negative, of course, is negative 2i. And then negative 2i times 2i is negative 4i squared. But notice what's going to happen. This is the whole point of a conjugate. This part right here in the middle, we would end up with 1 minus 4i squared, because if you notice, this part would just cancel out. And that's the great thing about working with conjugates. That's why this is done on purpose. The fact that it's a 1 minus 2i, we bring a 1 plus 2i because of this. All the variables in between will cancel each other out. Remember, we don't want an I to exist at the bottom of a fraction anymore. Now, I know what you're thinking, right? Like, look at the work that we did here. If we look at the work that we did here, and I put it at the bottom, I go 1 minus 4i squared. You might say, yeah, but you still have an I at the bottom. The whole point was to try to get rid of it. You have to remember what we learned the other day. We said as soon as you see that I squared, technically, let me write my numerator first. But technically, that means this is 1 now plus 4. Why? Because we said anytime you see an I squared, look, there's the negative 4. The I squared becomes a negative 1, but a negative 4 and a negative 1 became that positive 4. We just need to start moving straight from here to here, unlike what we did yesterday. And now we're pretty much done here. 3 plus 6i all over 5, and there it is. Our goal was to get rid of that negative that was at the bottom of our fraction, right, in our denominator. But now it's gone. And a lot of the times we do separate the real component, which means it gets the 5, from the imaginary component, which if you notice, it also gets that same 5. But just like that, that would be our answer to this problem here. Again, our goal is to get the I, that imaginary value, out of our denominator. And from now on, we see it here, this multiplication, notice, I don't want to have to multiply 4 times every time. The conjugate, that middle portion is always going to cancel out. So why show all that extra work when we know they'll cancel out? And in reality, if you notice, all I really multiplied was this and this. This is what we ended up multiplying for this problem. So now, knowing that fact, let's give it a try again. So if we look at number 14 here, it says 2 plus I over 3 minus I. Again, the issue is that radical right there at the bottom of the fraction. So here we go. All right. I'm going to multiply my denominator by the conjugate. The conjugate would be 3 plus I. But if I do it to the top, I have to do it to the bottom. Now notice, on the top, I do have a binomial times a binomial. And so if that's the case, I do have to multiply 4 times for that top value for our numerator. So here we go. Now for the numerator, let's see, it's 2 times 3. So we get a 6. 2 times I, so we're at 2i now. But don't forget, we still have more to go for this one. I times 3 is plus 3i. See, it doesn't cancel here. They're not conjugates. And then I times I is I squared, which we already know there's a change coming for that one. Okay? Now, at the bottom, remember what we just mentioned. Because they're conjugates, that middle portion is going to cancel out like we saw in the previous one. So in reality, I just have to multiply 3 times 3, so there's my 9. And then negative I times positive I is negative I squared. Now, we see two I squares, and that's fine. We're going to take care of them individually here. So let's see what we have for this one. This is a 6. The 2i plus the 3i, yes, we definitely combine those. We're with a 5i, but remember, here it is again. As soon as that I squared shows up, don't forget, it's going by a new look, -1. This one doesn't have a number in front of it. That's why I'm just writing a 1 for now. But then we look down here. Yes, there's a 9. There's a minus. But once again, we have this I squared right here. And it gets easier as you practice more and more. And so for this one, we also bring in a -1. So if you notice, we could have just called it +1, right? The idea is we're really just changing the sign of that value. And so let's see what we end up with. 6 and -1 is 5 plus 5i all over, yeah, that double negative becomes a positive, all over 10. Now, notice how in this one we do have 3 numbers that we're looking at. We can split them up so that it's 5 over 10 plus 5 over 10i. Remember, this brings back the rule that anytime you have a fraction, you should be reducing them at all times. So 5 divided by 10 is just half. 5 divided by 10 reduces to just half, but this time it has an I right next to it. And so there's our answer for this one here. So we just have to keep an eye on that. Be very careful, of course, with when you can reduce. And you saw the previous problem, no reduction can take place, so we didn't do anything with it. All right, let's keep trying these out here. Number 15, also very interesting. It says 3 plus 7i. So if it says 3 plus 7i, all right, there we go, a little clearer now. Tough to see. 3 plus 7i, I'm going to multiply it by 3 minus 7i. That would be the conjugate. And I know that if you look on top, we end up with the same thing. Remember, that does not mean cancellation. Only conjugates. That's where the middle values will go away. So let's multiply it through. Let's see what happens. We were getting too close there. Let's write it down here. So there's the big fraction. All right, here we go. 3 times 3 is 9. 3 times -7 is -21i. 7i times 3 with the negative is -21i. See, they don't cancel. They're not different signs. And here we go. -7 times -7, +49, but it has that I squared attached to it. All right, so far so good. Don't forget, this is when we, because they are true conjugates of each other, we will just multiply 3 times 3, so there's my 9, and then 7i times -7i. It's the only time that we're allowed to multiply just twice, which is -49i squared. Okay, now I see that there's 49i squared on both. That doesn't change anything. We're still going to do the work. We are going to combine these two, of course, but this is how we're going to start to save time. Look, -21 and -21, we're looking at -42i. Instead of calling it a positive 49i squared, remember, all we're really doing is changing the sign of it. Because I squared is -1, with that positive makes it a -49. Same thing at the bottom. Yeah, that 9 is patiently waiting. But when I see this -49 with an I squared, see, that -49 is now going to become a positive 49. So we always have to keep an eye out on those. Make sure that we're reducing and changing the sign. So let's see, let's simplify it a little bit more. So for this one, we have 9 minus 49, so that's -40. We do write it in front because it's part of our real value here. And then minus 42i all over. And then 9 plus 49, we're looking at 58. All right. Well, let's do our split here, of course. Now, some people like to reduce the numbers now so that when they split, they go straight into the answer. It's up to you. But I do have negative 40 over 58 minus 42 over 58i. But of course, these numbers do need to be reduced. So for instance, in this case, I believe 2 is the only number that goes into them. Let's find out. So negative 20, if I divide each one by 2, and again, decimals can do this for you. And then 58 divided by 2 is 29 minus, all right, we're going to do the same. We're going to divide everybody by 2 here. So 42 divided by 2 is 21 over 29 with an I. So they tend to get a little more complicated sometimes. Not too bad. But there they are. Now, I wanted to make sure that we got to that number 16 for one reason. It just says 3i. There is no conjugate for that. Notice, I know here it says 7i. And then you think about bringing in, all right, well, if it's 7i, let me bring in a positive 7i. There's no adding or subtracting below. So I do not need a full conjugate. The only thing causing the problem here is just the I. Same thing up here. I'm just going to multiply by just the I. Again, the 3 is not the issue. Since there's no adding or subtracting like the previous problem, we don't need a conjugate. The only issue is the I. And so by doing it like this, here we go, look. 4 times I is 4i. I times I, of course, it's negative. It's negative I squared, which we'll fix next on the next step. And then here, 3i times I is just 3i squared. See, nothing else, nothing more that we have to add to that. And so we clean it up. Let's get rid of those negatives. 4i, remember what we said, and I squared means negative 1. But if that's negative 1, with that negative, then becomes a positive 1. And then right here again, this is a negative 1. So my whole denominator becomes negative 3. All right, so we're going to split it so that we can have the real components and then the imaginary components on the side. But look at your real ones. We don't start off with the imaginary. So my answer is negative 1 over 3 minus 4 over 3i. Notice how I gave everybody the negative 3. That's why the 4 became a negative. I gave this one the negative, so the 1 became a negative as well. And we ended up with negative 1 over 3. Remember, make sure that you're writing them as a complex number where the real component is in front, the imaginary component is in the back. All right, we're going to take a break so you can try some of these problems out, and then we'll go on to the next step.